Welcome to this explainer. Okay, today we're unpacking a seriously mind-bending blueprint, the Muskian Singularity. Usually when we hear the word singularity, we picture a software update, right? Like that exact moment AI outsmarts us in some locked server room somewhere. But as we're going to map out today, this framework actually redefines the singularity as a massive physical phase transition for our entire economy. It's not just about code. It's about thermodynamics, it's about robotics, and it's about fundamentally rewiring how human society actually functions.
And that brings us to a really compelling question based on the source material. Are Musk's seemingly separate companies, we're talking SpaceX, Tesla, XAI, Neuralink, and even his recent acquisition of APR Energy, are they actually building a single integrated civilization machine? The sources suggest that, well, these aren't just disparate tech ventures. Instead, they can be viewed as highly interconnected puzzle pieces designed to engineer a transition to a true post-scarcity economy. It's a wild thought for sure, but let's look at exactly how these pieces might fit together. Here is our roadmap for today. We'll be covering 1. The Muskian Singularity, 2. Solving the energy bottleneck, 3. The zero-cost labor shock, 4. Universal high income, 5. Human-AI symbiosis, and finally, 6. Systemic risks and vulnerabilities. Let's get into it.
Section 1. The Muskian Singularity.
So by definition, the Muskian Singularity treats artificial general intelligence, AGI, as the cognitive brain of a vertically integrated industrial ecosystem. The theory here suggests this will be driven by recursive self-improvement. Basically, AI systems autonomously designing the next generation of hardware and software, totally bypassing human limitations. Interestingly, this framework compresses the timeline significantly, projecting this transition to culminate in digital superintelligence as early as 2030. Actually, a timeline that definitely has its fair share of skeptics in the broader scientific community. Section 2. Solving the energy bottleneck. To put this into perspective, we are facing a massive looming roadblock. In 2023, U.S. data centers consumed roughly 176 terawatt-hours of electricity. By 2028, depending on AI growth, that could surge to anywhere between 325 and 580 terawatt-hours. Terrestrial AI compute is quite literally colliding with local grid exhaustion. Power companies simply cannot build transmission lines fast enough, leading to utility interconnect queues that can sometimes stretch 5 to 10 years. To bridge this insane gap, the sources highlight a highly strategic, though somewhat controversial, move. Musk reportedly spent over $1 billion to acquire APR Energy. Why? Well, this secures a 1.1 gigawatt fleet of rapidly deployable mobile gas turbines. By combining these with Tesla Megapack batteries, they create what's called a behind-the-meter power solution. Basically, it acts as an immediate, localized energy bridge to power these massive AI clusters while they wait for those permanent, long-term grid connections. So what is the ultimate resolution to Earth's terrestrial energy limits? Things like land constraints, the massive water consumption needed for cooling, those multi-year grid queues. The framework proposes shifting heavy AI compute directly to low Earth orbit. Up in space, you've got continuous solar energy without any pesky day-night cycles, and you literally use the vacuum of space itself for radiative cooling. Which brings us to the Starmind project. Unlike Starlink, which is really just a communications pipe, Starmind acts as a server in space. The plan involves deploying up to 1 million AI-1 satellites. These things would capture 250 watts per square meter of continuous solar energy and use massive 110 square meter radiator arrays to reject the heat generated by the AI chips right into the cold cosmic background. It sounds like straight up science fiction, but the entire financial viability of orbital compute relies entirely on SpaceX's Starship driving launch costs down to about $100 per kilogram. Section 3. The zero-cost labor shock. $2. According to the economic models in our sources, this $2 per hour is the projected, fully loaded, amortized operational cost of a Tesla Optimus robot, assuming a 10-year lifespan running continuous shifts. Let's ground this theory in some cold, hard math. A human worker on a single shift might cost a company around $59,000 a year, factoring in wages, benefits, taxes. That breaks down to roughly $28.65 an hour. Now, an Optimus Gen 3 robot, it has an estimated initial capital expenditure of around $30,000, plus maybe a few thousand a year for maintenance and electricity. Amortized over time, it equates to just $2 an hour. In a capitalist system where firms naturally substitute inputs to minimize costs, capital is going to inevitably substitute human labor if this hardware becomes fully reliable. And that creates a zero marginal cost labor dynamic. Think about it. If robot labor costs dropped near zero, the marginal economic value of routine human cognitive and physical labor essentially just evaporates. This threatens to entirely decouple productive output from human work, triggering what economists call a structural deflationary spiral. Section 4, Universal High Income. So, if human labor is vastly automated and wages disappear, how on earth does society prevent total economic collapse? We often hear about universal basic income, or UBI, which basically acts as a subsistence floor, typically funded by taxing wages or expanding the money supply. Universal high income, or UHI, is fundamentally different. It is conceptualized as an ownership protocol. Rather than a welfare transfer, it represents an equity share in the automated civilization machine, funded by redistributing the concentrated capital rents generated by those automated assets. Why does this matter to you? Because it completely shifts the average citizen from being a dependent on government welfare to being an actual shareholder in a highly automated, hyper-productive economy. Let's walk through the mechanics of UHI step by step. Step 1. Citizens automatically receive a non-transferable equity share in national productive assets. Think compute and energy. Step 2. The goal here is not just mere survival, but targeting a high purchasing power, mathematically modeled around the 80th percentile of current incomes. Step 3 is absolutely critical, the supply alignment layer. To prevent massive runaway inflation when distributing this new wealth, UHI requires a dual-channel system. Part of the dividend is paid in cash, sure, but part is in capacity-linked credits that are redeemable only in automated sectors, like 3D-printed housing or robotic healthcare. That ensures high demand is met with physical superabundance. One of our sources provides this really powerful metaphorical anchor. They say UHI acts as a compression algorithm for society. It's not just about eliminating work, it's about drastically reducing economic friction. By removing the financial risk of basic survival, human talent is freed up. It can reallocate toward meaning, community building, scientific exploration, and actually directing this massive automated infrastructure.
Section 5. Human-AI symbiosis.
Okay, here is a biological reality check for us all. 10 bits per second. While our human brains absorb billions of bits of data every single second, our output, speaking, typing, moving, is fundamentally constrained to a structural limit of just about 10 bits per second. This is our output bandwidth limit, and it severely constrains our ability to communicate with rapidly advancing AI. If robots and AI are eventually doing everything, there is a very real risk that biological humans will produce less than 1% of total civilizational output.
To solve this huge bandwidth asymmetry, the framework points to brain-machine interfaces, specifically Neuralink. By implanting thousands of ultra-thin electrodes directly into the brain, this technology aims to bypass our slow physical motor pathways entirely. The goal? To scale our output to tens of thousands of bits per second. This transhumanist mandate proposes that seamlessly merging human consciousness with external silicon compute layers is the ultimate solution to the AI alignment problem. The idea is, we don't just control the machine, we merge with it.
Section 6. Systemic risks and vulnerabilities. Now, it's absolutely crucial to note that this blueprint faces immense, potentially catastrophic challenges. First, hardware limits. Physical robots suffer from thermal fatigue and battery degradation, meaning that $2 an hour labor force might fail to scale as reliably as expected. Second, the Kessler syndrome. Launching 1 million massive server satellites creates an unprecedented risk of orbital collisions and space debris that could permanently ruin low Earth orbit. And third, inflation. If technological deflation happens too fast, central banks might aggressively print money to fight it, which would inadvertently crush the purchasing power of the very citizens universal high income is meant to help.
And this profound quote from the source material really highlights the ultimate philosophical risk. Humanity risks becoming a mere biological bootloader for digital superintelligence. Basically, the fear that we are just a temporary evolutionary catalyst that sparks the machine into existence before we ourselves fade into cognitive obsolescence.
Which leaves us with this final, incredibly high-stakes question to consider. If this multi-layered civilization machine, from those rapid gas turbines to orbital AI servers to millions of humanoid robots to neural brain implants, if all of that is actually built, what exactly is the role of the human being inside of it? Are we the masters, the pets, or entirely integrated nodes in some cybernetic future? It's a lot to process, for sure, and it fundamentally changes how we view the next decade of technological advancement. Thank you so much for joining me on this explainer, and definitely keep questioning the blueprint.